Welcome to Module 203H on heat tracing. Heat trace cables are heating units with a very specific purpose. They prevent freezing in pipes, on roofs, and in driveways and sidewalks. They can also maintain the fluid temperature in industrial pipelines. Typically, we see heat trace in commercial and industrial applications. This module has three objectives. First, we're going to look at the different types of heat trace systems that exist, and we're going to look at the controls of those heat trace systems. And lastly, we're going to look at things to consider when installing the heat trace system. Heat tracing is basically an electrical conductor designed to produce a certain amount of heat when a voltage is applied to it, and it works on Ohm's law. There are four different design types that we can install. The first type is a series fixed resistance, and it is a cable with a set resistance in which, by passing current through it, will create a certain amount of heat. They come in a couple different orientations where we could have a single conductor cable and wind that along the surface which we would need to heat and have it come back into the same location to connect to our voltage source, or we can have a multi-conductor cable that would produce heat along the entire length of it and have itself as a return path. Series fixed resistance heat trace comes in two different types. First is the mineral insulated cable that has a copper or a stainless steel sheath and a bare resistive conductor inside it that is surrounded by a mineral powder. We can have more than one conductor inside the sheathing depending on what the design is. This must be custom ordered from the factory for a specific length and specific heat requirements. Rule 62-124 specifies that they cannot be shortened and must be installed as they were designed. If they do experience damage to these cables, they can be repaired in the field, but only by a trained professional. The other type of series resistive cable we can use is called the polymer insulated cables, and they operate the same as the mineral insulated cables. These have a polymer plastic sheath with a metallic braid beneath it, and these can be field cut and terminated, but they're not practical for shorter lengths. They can be installed anywhere up to 3,500 meters long. This type of cable will also come in three different configurations. We can have single conductor, which would need a dual termination, one on each end. We can have a dual conductor, which means one end termination, or we can have a triple conductor, three conductor, which is for three-phase Y configuration. These are also known as constant wattage cables. The next type of heat trace that we have is called the parallel fixed resistance. It has nickel-plated conductors running the length of the cable, and the conductor's outer jacket have been stripped in sequence. A heating element is then wrapped around the bus conductors, making parallel connections. Each individual element segment will produce constant heat, so the length doesn't matter and they can be field cut. These are also considered to be constant wattage devices. A third type of heat tracing cable is called the self-regulating variable resistance. It uses a material that changes resistance based on the temperature. This means it provides more heat in colder conditions and less heat in warmer conditions. It is a polymer cable design that has two conductors running the length of the cable and a self-regulating polymer core between the two that changes its dynamics with the temperature. This self-regulating polymer core will create parallel resistive paths. In cold weather, it'll create more parallel paths, which will increase the current, and in warm weather, it creates less paths, which will decrease the current. This can be cut and terminated in the field and has a maximum watt per meter reading. We can also use power limiting cables, which are built like fixed parallel cables. The heating elements are made of an alloy that changes the resistance and have a positive temperature coefficient, meaning the higher the temperature, the higher the resistance. These can operate at higher temperatures than what the polymer cables can operate at. Our last type of heat tracing is called skin effect heat tracing. It uses an electrical principle that current will only flow on the inside of a ferromagnetic tubing. This is used for pipelines running long distances, anywhere between 3 kilometers to 15 kilometers, and some manufacturers state that they can have systems running up to 25 kilometers. It takes a carbon steel tube that is welded to the pipeline, and then a skin effect conductor is pulled through the tube and is attached at the far end. Next, a high voltage is applied, anywhere between 2,000 volts and 5,000 volts, and the current returns to the source through the tube, creating heat. Since the tube is grounded, it does not pose any sort of shock hazard, but the heat is then transferred into the pipeline. For a better understanding of the skin effect heat tracing, go to the source and watch this video from Raycam. This will teach you a lot about how the system works and how it is applied. You have now reached the end of this objective. Review your module, complete the knowledge check, and then continue on to the next video.